Good afternoon, class. In today's video, what I wanted to do was to continue the work that I had shown you in the last video on the Lorentz transformation. In the last video, I did an introduction of it where I showed you the velocity transformations. The one thing I wanted to focus on, which is what I did which I touched on in the last video, was that I had the results x primed and t primed is equal to gamma x minus vt. Also, t primed is gamma times t minus v over c squared x. And I wanted to show you how to go from this function of x primed and t primed to x and t, and how to get that inverse. And like I told you last time, there was a lot of work that needed to be done, and the board here shows that I didn't disappoint. There is a lot of work to be done. In fact, not only did I have to write a lot, but I also skipped a few steps too. So there are some parts where you may want to pause the video, take a good screenshot of this, and actually work out some of the details for yourselves. But here we go. So first we're going to do this, so my basic methodology is I started with the substitution method. I was going to use solving for linear equations, and I used the substitution method in order to get the result that I'm looking for. And so, if you notice, I put the equation labels in red, and then I put the result labels in blue. And the reason I did that was that you could see a contrast when I actually get the results at the end that are actually the results that I want. So let's go through some of these steps, and then hopefully it'll, especially when we get to the next side, when we solve for the other variable, it'll start to make a little bit more sense about what I'm actually looking for, and also what I am, the method that I used, which is, it's exactly the same. So here we go. So I start with, I'm going to take my equation A, and I call the x variable x primed equation A, and then the t primed variable equation B. So I said I'm going to solve A for x. So I did that. I just, divided both sides of the equation by gamma, added vt to both sides, and there you go. Got my result. Very easy, but not very telling at this point. So then I'm going to substitute. So like we do in the substitution method when we're solving systems of linear equations, we take the result that we get when we solved equation A, plug it into equation B over here, and then solve it through that equation to get the unique result that we want. If you did this, if you took this result and plugged it back into equation A, you would be basically going in a circle, and that's no good. So here we go. Plugged it into equation B. I get t primed equals gamma times t minus v over c squared times the result that I got up here, for x. And then all I did was I distributed the negative v over c squared, so I got v over c squared times x primed minus gamma v squared over c squared times t. Now that is actually a really important result, but we'll get to that in due time. The next step that I'm going to take is I'm going to move everything. I'm going to move this x primed over to the left side of the equation here, and then I'm going to collect my terms. And normally I would do this in more introductory videos. I would have just done this one step at a time, but to save me some space, because I'm already running into the bottom of the screen over here, what I wanted to do was take two steps at a time. So I added vx primed over c squared to both sides of the equation, and then I factored out gamma and the factor t. Now, why did I put the t over here and not over here? Truth be told, it's because I wanted to really extract the t, the common factor of t from over here. Also, I wanted to factor out that gamma, because that factor is actually going to become important in the later steps. So I wanted to show that there was a distinction between them. I could have put the t over here, but I felt like it would have visually been a little bit confusing if I had actually done that. So that's why I did it over there. Then I realized that gamma is actually 1 over the square root of 1 minus v squared over c squared, illustrated right here. Now this is really important, because if you notice, I've got 1 minus v squared over c squared in the numerator over here. So this is basically this denominator squared, which is awesome. That's exactly what I'm looking for, because then when I actually cancel this out and simplify this, I get in the numerator the square root of 1 minus v squared over c squared, all of that times t, which I can now divide on both sides of the equation. So once I do that, I got 1 over the square root of 1 minus v squared over c squared, which should sound familiar to you because that is gamma. That is the exact result that we're looking for. So that's why I replaced it with gamma here. And then I've got my t prime plus v over c squared times x primed equals t. And that is the result that I want because equation D gives me is the result. This is the result that I'm looking for. That's the result that I got. So that's why check mark right there. Now let's go on to, now let's do the opposite and find this result for equation C. So in order to do that, I have to start at equation B and using the substitution method for solving systems of linear equations, I first solved the equation, I solved the t primed equation for t, then plugged it into equation A, and then solved for x. And so again, I did that over here. Notice when I did the same thing, when I did this, hopefully you're noticing that the same thing pretty much has occurred between this side and this side. The work is exactly the same. The only difference is the terms and the factors that are used in each of the terms. So once I did that, again, the same thing happened. I added, I separated all of the primed notation out. So x prime plus vt primed equals 1 over, or it will equal gamma times 1 minus v squared over c squared times x, which, that looks exactly the same as what I have written over here. So then when I go to the next one, when I go to the next line, and I've got this result here, that looks suspiciously the same. Like it's like all the work is exactly the same, and it lines up exactly the way we need it to. So, and that's actually the point. The whole point is that all of what I did on this side, I did the exact same thing on the other side, and I got the result that I'm looking for, which is that on the left side, it is the time is equivalent to the result that I want, which is equation D, and on the right side, that my result of x gives me equation C, because these are the two inverses to these Lorentz transformation values of position and time. So that was how to do the so that concludes that example, or the fleshing out of that little point that I made in the other video. In the next video, what I'll do is I'll do an example where I actually show what happens when you're traveling at different speeds, especially at relativistic speeds. So good luck in your studies, and may the force be with you.